Okay, so this is Science Paper 1, 2023 for internal candidates. It's saying figure B5.1 shows a ray of light moving from medium A into medium B. So what is happening here? The ray is coming from medium A going to medium B. So it is bending away from the normal, as you can see. So this line here, which is being represented by N, it is called a normal line. Okay, so what usually happens is like this. When you have a surface of water, and this one here is just going to represent a normal line. So suppose this one is a normal line, and on top here, we have air. Okay. Then down here we have water. So down here we have water. So in terms of what the density, water is denser than air. So air is less denser than water in terms of the arrangement of particles, if you can just apply that one. So what usually happens here when the ray is coming from less dense medium, which is the air. So when the ray is coming from less dense medium, which is the air, so after striking the normal, it bends toward the normal. So usually the rays, we show them by using the arrows to indicate where the ray is coming from. So this one is the angle of incidence, and this one is the angle of diffraction. So this means that when the ray is coming from less dense medium, which is the air, going to the high dense medium, which is the water, it bends toward the normal. Then oppositely, when it is coming from high dense medium, which is the water, going to the less dense medium, which is the air. In this case here, it bends away, not toward. It bends away from the normal. Okay. So let's try to answer the questions. So the first question, question A. Question A is, define reflection of light. So when you talk of reflection, this one is just the bending of light after striking a medium. The bending of light after striking a medium. So in this case here, reflection takes place on a transparent medium like a glass block, lenses, and so on. Okay. Then as for B, which medium is denser than the other? So to know which medium is denser than the other, we need to look at the ray. Is it bending away from the normal, or it is bending toward the normal? So when you have a plane surface like this one, so if this one is the air and this one is water, what is coming from the air, so it bends toward the normal. So that is how we represent. Now, as you can see, this one is not bending toward the normal. It is bending away. Bending away from the what? From the normal. This one can only happen when the ray is coming from high dense medium. For example, if it is coming from water going to the air. So what is going to happen? It is going to bend away from the normal. So in this case here, to represent the arrows, we can just say the arrows are going to be represented like this. So this one here is same as this one here. Now to identify which medium is denser and which medium is less dense, let's see the ray. This ray is same as this one, and this ray is same as this one. So which means medium A is denser than the other. So which means medium A is denser than the other, which is medium B. So medium A is denser than medium B. So we can just say medium A. C. Justify your answer in 5B. 1 mark. So to justify the answer here, just say when the ray is coming from high dense medium, it bends away from the normal. So you can just say when the ray is coming from high dense medium, it bends away from the normal. That's the answer. So if they were asking us to identify which medium is less dense, which means medium B would have been the answer. Question 6. Figure B6.1 shows two bar magnets that are held close together. The polarity on one side of one of the magnets is shown by its symbol. So when they use S, they just represent the south pole. So a magnet has two poles. So for example, if this one is the bar magnet, so this one can have the south pole and the north pole. Usually the north pole is denoted by capital N. And you need to know that always the magnetic field lines, they come from the north pole. So always the magnetic field lines, they come from the north pole. Okay. When released, the magnets push away from each other. Push away from each other. This can only happen when two magnets are held together and they are facing like poles. For example, if this one is the south pole and this one is the north pole, another bar magnet. If this one is the north pole and this one is the south pole, here you're going to find that there will be repulsion. Okay? There will be what? Repulsion. They're not going to attract. So when I say repulsion, it's more like the magnets are not going to attract to each other. They are going to repel. Because the magnetic field lines are coming like this, right? Yes. And a point here is going to be created, which is called a neutral point. So, when magnets are repelling to each other, they are going to create a point, and that point we are going to call it as the neutral point. Okay, so it is called a neutral point. So back to this one. Another one you can have something like here the north pole, the south pole. Then another one you can have south pole and also the north pole. Similarly to this one here, you're going to find that here there will be no attraction because like the poles, they don't attract. Okay? Like repose, they don't attract. And one thing that you need to know is that the south pole always receive the magnetic field lines. So for these to pull away from each other, which means the pole on this side here is same as the pole on this side here. So the question is saying label the north pole on each magnet shown. So they're just saying we need to label the north pole, not the south pole. Do not include the south pole. They're just saying label the north pole on each magnet shown. So for this magnet to pull away from each other, since here we are just having the south pole, so which means the north pole is remaining on this side here. Now for them to pull away from each other, which means even this one here is just going to be the north pole. Because like repoles, they repel, and unlike repoles, they attract. Okay, so that is how you're supposed to answer this one. B. Write one word which describes what happens to the magnets as they are released. So this one is called the repulsion or repelling. So we can say repulsion or repelling. So that is how you are supposed to answer. Question 7, which is coming from electricity. Question A. What charge is acquired by a material that loses electrons by rubbing? Okay, so here they are involving the electrons, and electrons are negatively charged. So which means what is going to be acquired here is just going to be a negative charge. So negative charge. B. Give one natural occurrence of static electricity. So static electricity usually occurs in nature by lightning. So we can just say lightning. Let's come to C. Figure B7.1 shows a circuit diagram with 3 different resistors connected to 24-volt supply. So we have the voltage being produced by the batteries or the battery. Then also have the ammeter, which is denoted by A. We have this resistor connected in series, and also these two resistors which are connected in parallel. So to find the total resistance of resistors connected, to find the total resistance of resistors connected in series, just say the total resistance is equal to resistor 1 plus resistor 2. An example, suppose you have here a resistor, another one here. So these are the examples of resistors connected in series. So this one can have 2 ohms and this one can have 3 ohms. So to find the total resistance of these two, just add 2 ohms plus 3 ohms. Then the answer or the total resistance is just going to be, so total resistance is just going to be 5 ohms. So that is how we answer for the resistors connected in series. Now, for resistors connected in parallel, like these two, we use this formula, which is 1 over the total resistance. So total resistance being equal to 1 over resistor 1 plus 1 over resistor 2, and so on. So if you have many resistors, you can use this one here. Now suppose you just have 2 resistors. If you have 2 resistors, you can either use this one here or you use this one, where you are going to say the total resistance is equal to R1 multiplied by R2 divided by R1 plus R2. So this one is only applicable when you have 2 resistors connected in parallel. If you have 3 resistors, this one, it is not applicable. It is only applicable when you have 2 resistors connected in parallel like these two. So we can just use this one here. So let's see the question. Roman number 1. Define resistance. So resistance is just the opposition of the electric charge in a conductor. When you talk of resistance, resistors, they act like friction force. If you talk of forces, they oppose the motion. Like when you talk of friction, it opposes the motion. Now specifically, when you talk of resistance, this one is just the opposition of the electric charge in a conductor. So the resistors, they act like frictions to the flow of charge. So it is just the opposition of the electric charge in a conductor. Then Roman number 2. Calculate the total resistance in the circuit. So we have these two being connected in parallel and only one connected in series. So we need to find the total resistance of these two connected in parallel and add it with one resistor connected in series. So we have 3 ohms and 6 ohms. So since we have just two resistors, so we're just going to use this formula. So total resistance is equal to resistor 1 multiplied by resistor 2 divided by resistor 1 plus resistor 2. So in this case here, our resistor 1 we can just pick as 3 ohms multiplied by 6 ohms. So our resistor 2 is just going to be 6 ohms. Then divided by resistor 1, it is 3 ohms plus 6 ohms. So when we multiply 3 ohms multiplied by 6 ohms, we are going to get 18 ohms. So we are going to get 18 ohms divided by 3 plus 6 ohms, we are going to get 9 ohms. So when I divide, I'm just going to get 2 ohms. Now this 2 ohms, it is for the resistors connected in parallel. We also have this one here, the resistor which is connected in series, which is just 2 ohms also. So to find the total resistance here, we are just going to say 2 ohms for the resistor connected in series plus 2 ohms for the resistors connected in parallel. Then the answer is just going to be 4 ohms. So this one is our final answer, our total resistance, which is 4 ohms. Roman number 3. What is the current in the circuit? What is the current in the circuit? So current, it is represented by capital I given by voltage over total resistance. So in this case here, in the diagram, they have given us the voltage, which is 24 volts. So I'm just going to put 24 volts where I'm having V. So 24 volts divided by the total resistance. So in this case here, the total resistance that we have here, it is this one here, which is 4 ohms. So divided by 4 ohms is equal to. So 4 ohms into 24 volts. The answer is just going to be 6 amps. So current is measured in amps. So the final answer here is just going to be 6 amps. The next one. Figure B8.1 shows a simple diagram of a transformer. So we have the input and also the output. Now, when we talk of a transformer, this one is an electronic device which can step up or step down the voltage of an AC. So it can step up. To step up is to increase. To step down is to reduce the voltage. Okay. So it can step up or step down the voltage of an AC, not the voltage of a DC. So when you talk of AC, it is just the alternative what? Current, the alternative current. So there are two types of transformers. The first one is a step-up transformer, then the last one is a step-down transformer. So how can you differentiate that this one is the step-up transformer and this one is the step-down transformer? So a transformer, it has two parts. It has an input part, which is called the primary coil. So it has an input part, which is called the primary coil. The output part, which is called the secondary coil. So, when you talk of the step-up transformer, the step-up transformer is going to have fewer number of turns on the input or the primary coil and more number of turns on the secondary coil. So an example of a diagram is this one. So on the primary coil or the input, we are going to have fewer number of turns. So this one is the input. So here we are just going to have fewer number of turns. Then on the secondary coil we are going to have main number of turns, which is the output part. So when you see such a diagram, it is going to represent a step-up transformer. So a step-up transformer, it has many number of turns on the output, which is the secondary coil, and fewer number of turns on the primary coil, which is also known as the input. So when you talk of a step down, it is just the opposite of a step up. For a step down transformer, you are going to have many number of turns on the input and fewer number of turns on the output. So if you see a diagram like this one here, which means this one is the step down transformer, because it has fewer number of turns on the secondary and more number of turns on the primary. So this one is the step down transformer. Okay, so let's answer the questions. Question A, Roman numeral number 1. What type of a transformer is shown in figure B8.1? So this one is the step down transformer. So we are just going to say this one is the step down transformer. So step down. Roman numeral number 2, justify your answer in A, Roman numeral number 1. Why are we saying this one is the step down transformer? This is because the number of turns on the secondary coil are fewer than the number of turns on the primary coil. So which means on the primary coil, which is the input, there are more number of turns compared to the secondary coil. So because it has fewer number of turns on the secondary coil compared to the primary coil, which is the input. Question B. Give 2 ways in which the efficiency of a transformer can be improved. Give 2 ways in which the efficiency of a transformer can be improved. Number 1, by applying oil or lubricating oil. So usually in transformers, they apply lubricating oil or just oil in order to improve the efficiency. Okay. So by applying lubricating oil or just oil. Then apart from that one, by using tight ion cores. By using tight ion cores. So, question B9. Question A. B9.1 shows some of the results of a competition among alpha particles, beta particles, and Y rays. Complete the table by filling in the missing properties. So we have the particles. So the first particle, it is the alpha, and alpha has been done for us. So alpha, it has a nature to that of helium. So it has a helium nuclide. Then the charge, it is plus 2 units. So where is this 2 coming from? So when an isotope undergoes alpha decay, suppose we have X been undergoing alpha decay, and this X is having 23 as the mass number and 11 as the proton number. So if this one here undergoes alpha decay, what is going to happen here is like this. It is going to lose, or the mass number is going to be reduced by 4. So suppose it is forming a daughter nuclide, which is Y. So if we subtract 4 from 23, we are going to remain with what? 19. So the daughter nuclide is going to have the mass number of 19. Okay? And then also, the proton number or the electron number, which is 11, is going to be reduced by what? By 2. So if we remove 2 from 11, we are going to get what? 9. So this one is going to be 9. Plus the nature of helium. Now, helium, it has a mass number of 4 and the proton number of what? Of 2. So, as you can see, this parent nuclide, which is X, it is giving out 2 electrons or 2 atomic numbers. Usually metals, they give out electrons. Once they give out electrons, they become what? Cations. They become cations. So when I say cation, this one is just a positive charge. Okay, so this one is giving out 2 electrons. So that is the reason why this one is having positive 2 units. Okay, let's come to beta. So as for beta, it has a nature to that of what? An electron. So we can just say electron nuclide. Electron nuclide. That's the nature. Then when it comes to the charge, suppose the parent of element X is undergoing beta decay by forming a daughter nuclide which is having a chemical symbol of Y. So what is going to happen to the mass number is that the mass number is just going to remain the same. So in this case here, we're just going to have 23 as the mass number. But the proton number or the atomic number, which is 11, it is going to be added by 1. So in this case here, we are going to have 12 here. Instead of having 10, we are going to have what? 12. 1 electron is going to be added, plus the nature of an electron. So the nature of an electron, it has the mass number of 0 there. Then here we have a negative charge. So which means, we know that non-metals, they do what? They gain electrons. Once they gain electrons, they become an ion. So what it means when I say an ion, it is negatively charged. So this one is negatively charged, depends to the number of electrons an element is gaining. If it is gaining 2 electrons, we say negative 2. Okay? Yes. Or if it is gaining 1 electron, we just say negative 1. Okay? But most of the times we just say negative. Or if it is gaining 3 electrons, we just say negative 3. So the nature is that of an electron. Then the charge, it is negative 1. Why are we saying negative 1? This is because it is gaining 1 electron. This is because it is gaining 1 electron. Let's come to Y rays. So Y rays are also known as the gamma particles. So as for gamma particles, suppose the same parent nuclide X is undergoing gamma decay or Y ray decay by forming a daughter nuclide, which is having Y. What is going to happen to the mass number is that the mass number is going to remain constant, which is 23, and also the proton number is just going to remain constant. Nothing is going to change here. So plus Y ray. So plus Y ray. So at the end, you just need to add Y rays. So in this case here, as for Y rays or gamma rays, they have the nature to that of neutron. So neutron, nuclide, that's the nature of gamma rays or gamma particles or Y rays. Then when it comes to the charge, since this one is not gaining any electron or is not losing any electron, it is just remaining constant, which means this one is just going to be neutral. And a neutral, it has zero charge, okay? A neutral atom, it has what? Zero charge, which means this one is going to have zero charge. Let's come to B. B is saying figure B9.2 shows 3 radioactive emissions, E, F, and G. A radioactive substance directed at 3 different obstacles. So we have a sheet of paper, a sheet of aluminium, and a sheet of lead. So a particle or a radioactive emission which can be stopped by a sheet of paper or a sheet of plastic, it is called the alpha particle. So E is the alpha particle. Alpha particle can be stopped by a sheet of paper or a sheet of plastic. And in addition, alpha particles, they can't penetrate the human skin. Okay? Alpha particles, they can't penetrate the human skin. So E is the alpha particle. Then the radioactive substance which can be stopped by a sheet of aluminium, which is F, it is called the beta particle or beta particle, whichever way you pronounce it. Okay, so beta particle or beta particle can be stopped by a sheet of aluminium. So F, it is just beta particles or beta particle. Then a radioactive substance which can be stopped by a sheet of lead, which is G, it is called gamma particles or Y rays. So in this case here they have used Y rays, so I'm just going to say Y rays. So now it can be stopped by a sheet of lead, but it penetrates about few centimeters. Okay, so which means we can conclude that a material which is suitable to make a box for storing radioactive emissions, it is lead, because lead can stop the penetration of Y rays, beta particles, and also alpha particles. Now, as you can see here, this diagram is showing the penetrations. Okay? It is showing what? The penetrations. So we can say that E, which is the alpha, it has lower penetration compared to what? G, which is the Y rays, or which is the Y rays, or gamma rays. So E, which is the alpha particle, it has lower penetration compared to the gamma rays. Gamma rays, they have higher penetration. Roman number 1, identify the emissions E, F, and G. So as for E, it is just the alpha particles. So alpha particles. Then as for F, it is the beta particles. Beta. Then as for G, it is called the Y rays or gamma rays. Then as for Roman number 2, give one difference between emission E, which is the alpha, and emission G, which is the Y rays or gamma rays. So here you can talk of 2 differences, or many differences if you want. So you can just say E, it is positively charged in nature. So E, which is the alpha, it is positively charged in nature. While G, which is the Y rays, it is neutral in nature. Then apart from that one, you can talk of penetrations. According to this diagram here, alpha particle, they have lower penetration compared to what? Gamma rays or Y rays. So you can say E, it has lower penetration, whereas G, it has strong penetration. Then the last one, you can talk of ionization. E, it has strong ionization, while G, it has lowest ionization. So those are the differences. So that was the last one. Thanks for watching, and remember to subscribe to my YouTube channel.